So hello everyone, thanks for letting me speak to you about Shapeless here. I'm really honored. And let's start. So let's start with a few disclaimers. First, all the code in this line is not just the product of my twisted mind, it's all actually compiled, so the compiler do validate what I write. And thanks to mdoc, which is a tool that compile code snippet in Markdown file. So great work for the guys at the Scala Center, especially Olaf and Jorge for this one. This is a work of fiction, so if you ask me if it's inspired by a real event, I would respond like Linus Torvald, no. Okay. What this talk is not about. This talk is not about recursion scheme, sorry. But so now what this talk is about. Well, it's about manipulating construct at the type level. So let's start, really. What is our agenda? We'll first take an example and explain the motivation around all this concept, all the idea behind this talk. Then we'll talk about schema, what is even a schema. And then we'll talk about manipulating case class at the type level with Shapeless, you might have guessed. So let's take up an example project. It's a relatively modern stack with microservices, an NoSQL database, JSON REST API, and a Kafka for events. Who would say that they have already worked in such a context, something along the side of this? Yeah, some people. With a stack like this, the most important thing is that there are a lot of independent services, a lot of independent software which has to communicate with each other. So serialization is a really, really important part of this kind of architecture. If we take an example, we might have like a user service, a small snippet or complete project. We might have a small service, a user service, which communicate with an NoSQL database to modify its state and then push message to Kafka, for example, to say this user has been deleted, and have another service that listen to these messages and say, for example, clean up stuff after the user has been deleted with its NoSQL database. And so we have a user service, so we might have a user, right? And this user must be a first name, a last name, an age, creation date, and a permission. And we can represent this kind of thing easily in Scala because Scala is great at modeling data, right? So we just put it in a case class and we are done. We put types and everything works. But then we have to write this over the wire. We have to serialize this data. And so we write a serializer. And again, it's really easy to do. We just have to use the API provided by the play JSON library, and it kind of works. And we create a user, and we write it. But unfortunately, my colleague was very drunk when he wrote this one. And our friend Donald the Duck just got a little bit older. This is an obvious error, right? Did you notice that I misspelled permissions? Maybe, maybe not, but your end user might. So the problem with this is that it's perfectly valid compiled code, but completely wrong. So how do we avoid such mistakes? Well, we can generate this writer. And it does work without mistake. It's great. Less line, less chance to get things wrong. But now, what if we remove a field from a user? Well, we might just have broke compatibility with our end users, right? Basically, somebody might have used our permission field. And we did not know it because there is nothing in this part of code that tells us, hey, take care, you have just changed your API. Even worse, what if we decided to store our password in the same class? Great, it's easy to do. We just add the password field. And then we just have sent up the password of our users over the wire. I do think the security team might not really happy with these kind of things, right? So one can think that it means that automatically generated code is evil. Maybe automatic derivation is bad. But is it really? Well, I advocate that the problem here is not that much about the generated code, but it's more about the fact that we couple the way we represent our API data to our model, our domain model. And basically, coupling is bad. So if we want to decouple things, if we want to be able to change our model without breaking everything, we need to add another layer. And the question is, what is this other layer? Maybe we need a schema. Maybe. Why not? Maybe we need an intermediate definition language. I don't know. But let's go on schemas. What are schemas? Well, actually, schemas come from a Greek word that I will not try to pronounce, which means shape, or more generally, a plan. And it's really intuitive. It's the form of our data. It's like some constraints, well, to quote it again, shape. If we take this example in another context and we put it in the context of a relational database, a schema is a way to represent constraint of our table, the content of our table, and relationship between these tables. So basically, a schema is a way to define constraint and a way to define the relationship between our models. Right? It may be a simple definition, but it's at least a definition. And the thing is, we already can do that in Scala. We have types. And with types, we can model everything I've just said. We can model constrain our data with types, base types, string, refined type, string with length 2, I don't know. We can say what is in our type. We can say we have case class. So we can say there is a first name, a last name. And we can also define relationship. We can define inheritance with algebraic data type. We can compose with, for example, we could put a group ID in our user to say there is a relationship with a group. I don't know. So type is our way to define a schema. So maybe what we need is more type, right? And if we follow a domain-driven design, it makes sense. Basically, you don't want to have you want to have separate model for separate domain. So basically you want to have a separate model for your API than from your domain model, right? And if we consider types as a schema, we can maybe apply some techniques that we know about schema. For example, you have maybe heard the presentation this morning about schema evolution in Avro. Avro, which is a serialization format you can use, for example, along Kafka or Spark. And they define a set of operations you can make on types. You can add a field, optional or not. You can delete a field, optional or not again. Or you can modify a field, which is basically a deletion and adding the field again, another field again. And they also add two concepts. Basically, the backward compatible change, which is the fact that new consumer will be able to read all data. And we can summarize it or simplify it a lot by saying that we can find a function which goes from the old schema to the new one. And what operation we can do that maintain backward compatibility is deleting a field or any operation on an optional field, right? But there is a forward compatible operation, and it's exactly the same but reversed. So basically, it means that an older consumer will be able to read the new data. And that means that we can derive a function from the new format to the old one, right? And basically, it's exactly the opposite in terms of operation. So let's try that. Let's say we define two case classes now. Now we have a case class for our user domain. So the representation of what the business see in our user, and a representation of the format we'll send over the wire, or for a GET. So GET user API, right? Well, it's easy to find a function which goes from the user domain to the user API. We just have to fill in the blanks. And it works. And the compiler will check, provided sufficiently precise types, the compiler will check everything. And we can generate or get user API. No problem. And it works well. It does. Basically, now I cannot make a mistake. Of course, I can change the API type, but I can put a big warning in the head of the file. Don't change that, it's a contract, you know. So it works. but it works with a ton of boilerplate. And I don't like to write boilerplate. And the question is, well, the problem is that this code does not bring anything to the business, right? Basically, it's just if you start doing that and you start writing everything like that, you'll have a get user API, you'll have a create user API, you'll have a update user API, you'll have a type for everything, and then you'll have a function to convert this type all over the place. So it's really annoying to do, and it will slow you down. So the question is, why can't the compiler do that for us? And why you might have guessed what I'm about to show you. Well, the talk is about Shapeless. We'll see if we can transform this data with Shapeless, right? So now that we have a better understanding of our problem, let's try to restate our goal. The goal is to transform data. We want it to be done at most at compile time. We want it to be type safe, and we want to write the minimal amount of code to actually make it work and make it safe. But when you want to write, basically we want to execute code at compile time, but we want to execute code. So we need a runtime, but a runtime at compile time, right? Basically, we want a way for the compiler to give us a way to execute arbitrary code. And we have actually two ways of doing that in Scala. We have macros, and we have implicits. And as people might have guessed, if you are familiar to Shapeless, in general, when you talk about Shapeless, you talk a lot about implicits. So we'll focus on implicits. So what are implicits? Well, implicits are basically a way for compiler to fill the blanks. And they have a lot of uses. Among them is passing implicit context, like implicit parameter of a method, extension method through implicit class. For example, cats rely a lot on them. We have composition, because implicit do compose. And we'll focus on implicit composition for a while. But to understand implicit composition, there is a very simple concept you have to understand. It's really simple, but we are not so much used to it in the wild, because a lot of language does not support it really well. The JVM, for example, does not support it really well, and it's recursion. What is recursion? Well, recursion is the fact to define something using itself. Quite simple. So if we take the definition of a list, well, a list is either an empty list or an head concatenated to a tail, right? And this tail is a list. So basically, it recurs over the tail of the count. So that's a recursive type. Now, let's take a simple recursive function. Let's define a length which is recursive, a recursive way of computing the length of a list. Well, again, no big deal here. If the list is empty, its size is 0. If the list is not empty, then it's 1 plus the length of the tail. And let's just go through the steps. So if I have the length of a list of 1, 2, 3, then I'll go to the next step, and I have 1 plus the length of a list of 2, 3. Then again, I'll go to the second case, and I have 1 plus the length of a list of 3. And then I go again to the, then I go again to the second case, and then I go to the nil case, which is 1 plus 1 plus 1 plus 0. That's really easy, isn't it? Now, the question is, can we do it at compile time? And the answer is no. Not like this, because there is absolutely no information. The compiler has absolutely no information on what is the size of the list. So basically, we have to give it the information it needs to actually do the computation. So let's modify slightly our definition of a list. So it might look scary, but basically the only difference is that my t is I have an extra parameter t over which is actually an S list. So it's the only difference. The method inside are just for convenience, right? And the name is a bit weird, but it's because it's more convenient later. And if I define a list with such a type, I will have this. And what is interesting is that, well, now I have the type information I need to actually compute anything, the size of this list. Because now, rather than having just a list of int in the second example, I have something which is an int concatenating to an int, concatenated to an int, concatenating to nil. So now I can define the size, and I can define the size this way. I can say this size is just an int, right? So the size of t is an int. And then I can define a companion object which basically allow me to materialize this implicit just for convenience. But what is really important in this part. And then I can apply the same technique. I can say, well, the size of a nil is 0. And the size of a concatenation, well, actually, it's the size of the tail plus 1. Right? So basically, if you want to read that, you can read that this way. Given the size of t, I can give you the size of h const t. H is not bounded, so for any h, I can give you the size of h const t. And it does work. Great. So just for the sake of the argument, let's decompose what the compiler does. Well, it searches a size of an int, const int, const int, const nil. Well, it's a const, right? So it will fall into the second case. But then it needs the size of an int, const s nil. So it will again fall into the second case. But then again, it needs the size of an int, const s nil. So it will again be the second case. Note that I am forced for variance reason to help the compiler in its type inference, but basically it's not really what is interesting here. And then I have my last case, which is nil. So my base case. And if you squint hard enough, you can see a real similarity with what we have done just before. So that's my point. For our purpose in this talk, we can consider that basically implicit composition behave like pattern matching and recursion over types. So now, enough introduction, right? So what we want to do is transform an A into a B, where A is a case class and B is another case class, right? And again, I will have a way to materialize this implicit just for a convenience method. But what is important is that I want to take an A and make it into a B, right? So, but let's start really simple. Let's start with only field deletion, and we will not transform our types, right? We'll just like project our data from a type to another. The question is, how would we do it at runtime? Just by using recursion and pattern matching. Well, we could define a set of types, which like just a minimal type system, which basically says that I support ints, I support string, I support boolean, and I support tuples, which are basically a list of types. We don't care about the size of the list at the moment. And then what we want to prove is that from from A we can extract every information we need to go to B, right? And so we can do it this way. So basically we have, if B is nil, it means that we have extracted everything we need to construct a B, so we can stop. It's our base case. Then, if we have heads that do match, well, we can just take the head of A and concatenate it to the recursive step where we try to transform the tail of A into tail of B. And finally, if the head do not match, well, we can just try to try to transform the tail of A into a B. It will not work in all the cases, but given our previous assertion, it will work, right? But does it work? Well, we can see that we can transform. We have basically an identity function. It does work. And we also can like zoom into types. And it does not work if we have incompatible types. OK, so it does work. But now, again, let's do this at the type level. But we need a way to represent our tuple at the type level. And we need a way to recurse over this tuple. But there is already a way provided by Shapeless, and you might know it by its name. It's an HList. And it's really similar with what I showed you before, except that my H parameter is not constrained. Before it was, I kept the H parameter to constrain my list. So it was if the first parameter was an int, every subsequent parameter would be an int. Now it's not constrained anymore, which means I can have something like that. I can have an int, const string, const boolean, const hnil, right? And I can go from generic to HList without any problem, because it's basically they are isomorphic. If you have heard the talk about the QA session of Martin Odersky, tuple in Doty are even encoded as HList by default, so they are completely similar. So again, let's do it the same way we did it at the value level. Let's do it at the type level. Well, we have our base case, which is the case where we want to transform something into a nil. Well, no problem. We just stop. We have already extracted everything we needed from A. So basically, we stop, we return hnil. And it gives us a really not useful function, which transforms anything into an hnil. Great. But now, let's get real things started. Now, we have our second case to do. Well, here our head do match. And what does it say? Well, it says, well, if you give me a way to transform a tail of A into a tail of B, then I can give you a way to transform the head of tail of A into an head of tail of B. By the way, this is a simple abstract method. So basically, as transform is an interface with only one function in it, one method in it, I can just use a function instead. So I don't have to write new transform, blah, blah, blah. Most of you guys might know it, but just in case. So basically, at the type level, it's kind of involved. But at the value level, it's really simple. Basically, once I know that, I just take the. I know that basically I can take the head. This head is the same, so basically I just have to take the head and concatenate it to the transformation of the tail of A, right? So head do match. So now I still can't do much thing. I can basically transform something into itself, right? Because I have only the case where I have nil on the case where heads do match. On case where heads do match all the time until it's a nil is basically an identity function. Now in the case heads do not match, well, in the case heads do not match, well, then I have exactly the same idea. Basically, I say, given a transformation from tail of A to head of tail of F, const head of B const tail of B, then I can give you the transformation from head of B const tail of A, which is an A, to head of B const tail of B, which is a B. And we just ignore the head. Great. Now I can transform. I can actually do transformations that might be useful. That's great. But we do not handle often tuple. We want case classes, right? Because tuples are not practical, not really that useful. Well, it so happens that case classes are not that different if you introduce another type, another concept, which is a tag, right? It's a tag is basically a string, a name, the name of your field, and its type, right? And by doing so, I have basically nothing to do to make my previous function work, because the pattern matching, the equality, will already check that, and it will already do things the same. It will do things the same way. Basically, if the head do not match because age has not the equality of name, so it stops, and then the name do match, so it takes the name, and then I have nil. Nothing to do here. And if I am wrong about the name, again, equality will just stop me. And that's just called a LabelledGenerics. So you can't really see. I'll try to show you. But basically, there is unfortunately, with compiled slides, sometimes you have to work with the formatting. So basically, what it says is that A, it's an int with the key tag, symbol tag, param1, and concatenated to a string with labeled key tags with tagged param2, right? So that's the idea. And so we need a way to transform our case class in an HList, and then we'll be able to use our actual implicit to this case classes. And it so happens that Shapeless provides us a way to do that. And again, it's a bit verbose, but it's not that complex. Basically, it says given a way to transform an A into a generic representation A, and given a way to transform a B into a representation of B, generic representation of B, and given a transform from the generic representation of A to the generic representation of B, then I can give you the transformation from A to B. And again, at the type level, there is a lot of stuff going on, but at the value level, it's really intuitive. Basically, you transform your A into the HList, then you transform the HList into the HList of B, and then you transform the HList of B into a B. That's it. So let's try it. Let's take our user domain and our get user API, and let's go from one to another. And it does work. And remember, this style compiled, so the compiler is happy, and it will create a user domain with a get user API with our user domain without any complaint and without any code. Well, we can do a few more things with it. We can automatically wrap or unwrap things, for example. We can say, well, if I have an A, I can give you an option of A. I just wrap my A into an option of A. Although I can just take a user ID, a value class, and just give you the types in it. I can just unwrap things without any loss, right? And then I don't basically I'm just adding my transformation. I just added cases to the sort of like implicit pattern matching and recursion that the compiler does. And actually, if I just add that, it does not work. So again, I have to add a real case. And promise it's the worst I will show you. So basically it says, and it's again the same thing. It's given a way to transform a node of A into a node of B, given a way to transform a tail of A into a tail of B, then I can give you the way to transform a node of A to a tail of A, to a node of B to a tail of B. So basically, it's a generalization of our case, or the case where our heads do match. And it allows us to actually transform an HList. So let's go to production, right? Well, with this, you will have a compiler to keep you warm in winter, because implicit resolution, as we all know, is really fast. We'll definitely have overhead at runtime, because, for example, to go from a case class A to a case class B, well, we have to go to the case class A, to the HList A, to the HList B, to the case class B. I will not say that will be a problem for most applications, but definitely there will be an overhead. And there will be definitely helpful error messages. Something did not work. What? I do not know. And for example, what about if we mess with field orders? Well, actually, it does not work either, because it expected, or previous example expected that the fields were in the same order, right? So it does not work. Actually, there is a way to make these things work, and as will probably, because I've been far too fast, I will have the time to show it to you. But first, I will conclude saying, don't throw this ID away, because you can use Schema. And Schema is basically what I've showed you, but using macros, which have the great advantage of having correct error messages. So basically, it's saying, yeah, I cannot convert from your type because you don't give me a way to extract a full name or a legacy user. So now the compiler tells me what's actually going wrong. And it gives you an API to actually complete what the compiler cannot find by itself. So basically, here I can say, I can tell him, yeah, actually full name is a computed film, which takes the first name and the user and concatenate it to the last name. And again, you can add constant, and there are a lot of other transformation you can do. It's handle value class wrapping and unwrapping. You can ask him to just put none when you have option and he cannot find them. A lot of things you can do. I'm not saying you should do them, but well. So to wrap things up, well, in general, it's a good idea to avoid coupling. I'm in the opinion that you should add more types, and you should derive all the things. To go further on this question, there is the type astronaut guide of Shapeless, which is basically the best resource on Shapeless, I think. There is a great talk from Chris Burchell, which is called Messaging Case Classes with Shapeless. We can explore a bit what you can do with Schema in the same way I did really fast here. And of course, you can just check the documentation of Schema. Thank you. The slides are available at this URL. I'm Kévin Rauscher, a freelance Scala developer, and you can find me on Twitter and with the keyword @Thomas. And as we have been really fast, I will show you the way of really quickly the way to solve the problem with order in your types. Basically, the idea is that you, rather than using the equality on head, basically you change it a little bit to use something that is provided by Shapeless, which is a selector which says that basically I can extract an head of B from an A, and then I just, rather than using the head, I just select the type I'm searching into the HList, and I concatenate it to the transformation. The same idea given blah 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 blah. And it does work. And I have bug in my slide. Great. Sorry. Any question?
Sorry. It's a really painful theme for me. I'll tell a sad story. We got Boolean from backend side. First time it was true. Second time it was 1. Third time it was 0. And fourth time it was null. All of a sudden appeared that null has different meaning than false. So what we should do in such cases?
I have not catched your question. When do you happen to have this problem?
It appeared from backend side written on PHP.
Oh, well.
And last shot, sometimes we can get empty array.
Well, I don't think there is a great way to handle things there, because if you cannot know what type it is, well, you can do some things. Basically, you can write. It depends on the data you are using. For example, if say you want you have an int, and for some reason sometimes they send you an array. The question is, what is the correct business way to handle it? Are they different types? Are they actually different messages? Does the array just don't make sense? Should we use null, for example? Should we use none? So it depends on the business. But what you can do is write a special type, for example, and have a, you could have, for example, a seal trait. We said where the PHP type, which can be either an int or nothing or an array, and then you pattern match on it. So basically, you have this like weird construct at the type level that helps you to encapsulate what they maybe are trying to mean. It really depends on your business need.
Hi, thanks for the talk. My question is a bit not exactly related to this technique, but would be interesting if you consider it when you have multiple types for different operations on your API, let's say, and you have a domain type, do you want to avoid, let's say, if you update your domain type, missing these updates in your derive types in these operations? Have you thought about this problem?
Well, you don't completely have you have not completely decoupled things, right? Because basically you're saying that if you can find all the information you need, well, you can derive this. If, for example, you delete something, the compiler will just say, "Hey, I cannot derive the transformation anymore. Help me, please." So you have basically you don't decouple thing, but you add a certain of you don't decouple it completely, but it becomes loosely coupled. So basically, you have operation you can do without having to you'll have to recompile your code base, but you don't have to modify anything else, right? As you said, another pain another itch it's the scratch is that IDs. For example, when you create an entity, often you attach it an ID, but this ID is never client-side generated, right? So the problem is that you have several options. If you just have one model, maybe you put an option here, but it's annoying because you have to handle the option every time you treat this model. While actually your optional will be none like for a few milliseconds, the time for your database to actually put an int in there. So if you actually decouple things, and for updates the same way, well, you can say I don't allow to update all these fields. So basically, it's purposeless to read them, and it's even worse. It's dangerous to actually read them because you give the ability to somebody to actually hook them to the business the update of your actual entity, and put things that should not modify things that should not have been modified. So so I hope it answered your question.
Okay, but what about when you like add like a new field to a domain object, and it might be useful for like let's say get operations or other operations. How do you not forget to add them later if they are decoupled?
Yeah, you have to add it by hand. That's right.
Okay, so you have to remember.
You have to remember, but
Okay.
when you test your feature, hopefully you'll test that you receive your correct message, and so you then are reminded, you know.
Okay, thanks.
So it's not a silver bullet.
Yeah.
So hello, I saw in your slide that the transform between two case classes depends on the AUX type. So what it is and how it's implemented.
So you mean this one, right?
Yeah, that's one.
So great question. Basically, it's an helper to have the correct types. It's a way basically. It's a way Shapeless. The LabelledGenerics type. I think if I remember correctly, it takes 3 types, but they are basically there is an inner type. There are weird shenanigans that Shapeless do, and this helps us to get the types right. It's mostly that. I cannot explain that in like 5 minutes. Sorry.
Hi, thank you for your speech. Actually, I was waiting for somebody to explain something using Shapeless. So, as we know, most of the libraries, they were using Shapeless, like, for instance, there's Magnolia for type class derivation, there's Schema for mapping case classes. We can do the same with Shapeless, but it may compile ages. How do you think, what are the cases where Shapeless is still very needed?
Well, so I'll quote someone else like that. For that, Shapeless should not be needed. It should be in the Scala compiler, and it probably will be in Dotty in a way because Miles has joined the EPFL team. So for this, you cannot use Magnolia. I don't think you can use Magnolia because you have to you need a way to deconstruct deconstructed view of your two types. So I've not seen example of Magnolia doing so. Maybe John has an idea on this, but I don't know. In general, macros are much more efficient way to do things when they work. And debugging a macro is way harder than debugging an implicit. So for at least for prototyping, it's really nice. And there are libraries that still use Shapeless, for example, CRC, which is performant. So basically, the HList transformation does not bother it so much. So in general, I've played a bit with Magnolia, and I've not played so much with macro. But I prefer to write code with Shapeless, but it's because basically, if it compiles, it works in general. While with Magnolia, you have to do some weird things like cast and stuff like that because it's a really different view on things. But for performance reasons, macros are better in general.
Yeah, but this may be a bit tricky. Yeah, for instance, who tried Frameless, for instance? Less people, yeah, it's some kind of wrapper around Spark SQL. So if I messed up with some case class fields or in the select or join, it won't compile at all. So I need to look at and find the mistake with the types. And this is the main problem using Shapeless, I think.
Actually, there is a thing. If you look at what I said about the drawbacks, well, so this one hopefully will go away in Dotty because basically, if tuples are HList, maybe case class will be backed. Logically, case class should be backed by HList, so the overhead just go away. It depends on the Dotty compiler, and this again the same thing. But there is work going this way from the EPFL team, so hopefully we can rely less on macro. I think it's one of their goals, so less macros, more meta programming like this. So hopefully in the future it will be better.
Thank you for a great talk. I heard from in Twitter from Miles Sabin that Shapeless relies on dependent types, but I wonder how they implement it, because Scala doesn't support it like on the language level. What tricks are they using to achieve dependent types in Shapeless? Thank you.
For Shapeless and dependent time, honestly I cannot answer you. And for the case of this presentation, there is actually something that I silenced, but this is a macro, for example. No, this is not a macro, but this is a macro. And this style of transformation are made by macros because just implicit would not fit. So basically, to go from from tuple to HList, it's a macro. But after that, it's only I don't. There is. I'm not sure how to answer your question, honestly. Well, then great. Thank you.